Good morning, everyone. Today we are going to see about the nonlinear data structure, that is about trees and graphs. So first, what is nonlinear data structure? Nonlinear data structure is a data structure in which the data may be arranged in the hierarchical manner, which means the data elements are organized in some without arbitrary functions, that is without any sequence. That is called a nonlinear data structure. So the example for nonlinear data structures are trees and graphs. So this is an example for the tree data structure. Then what are the types of nonlinear data structures are available? So basically data structure is classified into linear and nonlinear. We will have a linear data structure we have arrays, linked list, stacks and queues, and for nonlinear data structure we have trees, graphs, tables and sets. Now we are going to see about the trees. So tree is a nonlinear data structure. The data are arranged in a hierarchical manner without following any sequence. So this is an example for the tree. Here we have a tree with the nodes. So first one is called as a root node. Then it is at the root node is at the level 0. Then B and C at the level 1, and D, E, F, G are at the level 2. So this DHI is referred as a subtree. The node which does not have a child node is referred as a leaf node. The nodes which are at the same levels are referred as a siblings. So this is about the basic terms. So first we will see about the root. So root is a node. This is the first node in the tree. So every tree must have the root node. We can say root node is the origin of the tree data structure. And second, edge. So edge is a connecting link between two nodes is referred as a edge. If we have a n nodes, there will be n minus 1 number of edges in the given tree. Then parent. So parent node. So the node which has a child node is referred as a parent node, child node. In a tree, the node which has a downwards links is referred as a child node. Then siblings. So the siblings means no, the nodes which are at the same levels are referred as a siblings. Then leaf node. The node which does not have a child node is called as a leaf node. The internal node. So the nodes which has at least one child node is called internal nodes. The next term is degree. So the degree of a node is referred as the total number of children it has. The highest degree among all the nodes in the tree is called degree of a node. Then level. The level means the nodes at the tree set level starts from 0 and we will go up to level 1, 2, 3, 4 up to 5. Then height. We will calculate the height from a leaf node to a particular node in the longest path. That is, we are measuring from the downwards to upwards. Then depth. Depth means that is opposite to the height calculation. We have to calculate the depth from the root node to the particular node. Path. So the traveling path is referred as a path. Subtree. In a tree, each child from a node to it forms a subtree. Then next, binary trees. Binary tree is a spatial data structure. The condition that each node can have maximum of 2 children, that is called binary trees. What are the types of binary trees? Full binary tree, complete binary tree, extended binary tree, left skewered binary tree and right skewered binary tree. So what is full binary tree? Full binary tree means every node should have exactly 2 children or none. So it should have either 2 or 0 number of children. That is called full binary tree. Then complete binary tree. So complete binary tree in which all the nodes are at the same depth. Extended binary tree. We can convert a binary tree into full binary tree by adding dummy nodes to existing nodes wherever required. That full binary tree is obtained by adding dummy nodes to the binary tree. This is called extended binary tree. Then left skewered binary tree. Binary tree which has only left child nodes is called left skewered binary tree. And binary tree in which each node is having either only left subtrees or no subtrees is called left skewered. Then right skewered means a binary tree which has only right childs, that is called right skewered binary tree. Next, tree traversals. Traversing means visiting each node of the tree exactly once. Traversing, moving through all the nodes in the binary tree exactly once. So what are the types of tree traversals? In order, pre-order and post-order. In order traversal, first we should visit the left node, then visit root node, then right node. These are the steps. Then pre-order. So in the pre-order traversal, we should visit the root node first, after that left, and then after that right node. So post order traversal, so we should visit the left node first, and then right node, and then root node. So this is about the traversals. Next, binary search tree. So binary search tree is a binary tree in which the value of left child is less than the root node and the value of right child is greater than the root node. This is the condition for each and every node in the tree. So this is an example for the binary search tree. So what are the operations we can perform in the binary search tree? Insert, delete, search, and display. So insert, we should insert the tree by following the conditions that root node should have a maximum value compared to its child nodes. So this is insertion. And deletion, we will have three types of deletion. If a node have a no children, if a node have a non children, and if a node have a two children. If a node have no child nodes, we can easily perform the deletion. Just simply delete the node which we want to delete. If the node has one child, move the child to the position where the node we should delete. Then deletion of a node which having two children. So in this we should move the we should consider the right subtree, and in that right subtree which node has the least value, that value should be moved to the deleted position. So this is about the deletion. Then searching. So searching means we are searching a required data in the tree by visiting each and every node in the tree. So we should start from the root node, then if value is found, it will be returned. Otherwise, it goes to left child. If the value is greater than the node, it goes to right child. This condition will be followed. This is about the searching. Then these are about the insertions and deletion. Example for the insertion, deletion, search operations. Then graph. So graph is a collection of sets, vertices and edges. So vertices and edges are referred as a graph. So in this example, we will have a vertices A, B, C, D, E, and the edges AB, AC, CD, DB, DE. What are the types of graph? Directed graph. First, we will have a directed edge in the graph is referred as directed graph. Undirected graph. In the graph, there is no direction. This is called undirected graph. Weighted graph. In a graph, if a edge has a number, that is, it has a weight, it is called weighted graph. Complete graph. A complete graph means if a graph has n vertices, it consists of n into n minus 1 by 2 number of edges. Then that graph is referred as a complete graph. Subgraph. If it derive a graph from a on graph, that is called subgraph. Connected graph. Connected graph means each and every vertex should be connected with each other. That is called connected graph. Cycle graph. If a graph has a cycle, that is a path which forms a cycle, is called cyclic graph. Acyclic graph means a graph which it has no cycles is called acyclic graph. Symmetric graph is it is a directed graph such that for every edge there is also a reverse edge. That is called a symmetric graph. Representation of graph. We can represent the graph by two ways, that is adjacency matrix and adjacency list. Adjacency matrix means we are forming a matrix with the number of vertices. If the edge is present, we should mark it as a 1. If there is no edges, we should mark it as a 0. Then adjacency list. Adjacency list is represented using the list data structure. If there is a connected edge, then we should represent using the double linked list. Next, graph traversals. So graph traversals, it has a depth first search and breadth first search. So breadth first search is implemented using the queue data structure. So what are the steps we should follow means define a queue size of total number of vertices in the graph. Then we can choose any vertex as a selecting starting point for the traversal. Visit that vertex and insert into the queue. Then next step is visit all the adjacent vertices of the vertex which is at the front of your queue. If it is not visited, and insert them into the queue. When there is no new vertex to be visited from the vertex at front of the queue, then delete that vertex from the queue. So we should repeat the step 3 and 4 until the queue becomes empty. When the queue becomes empty, we can produce the final spanning tree by removing unused edges from the graph. This is the algorithm for BFS. So this is the example for BFS. Then depth first search. So the same concept, we are implementing the depth first search using the stack data structure. So this is about the trees and tree traversals and what are the types of trees and everything. Thank you.